Oh, hey, hello everybody. Olá, from Portuguese Brazilian, and welcome to our Fabric Talks, our fourth session of the second installment, right? The second series. Welcome to the space. My name is Armando Lacerda. Here I have my friend Tiago. Hey, Tiago.
Hello, hey Armando. Hey everybody. So it's
Hello
a
here
pleasure
from
to be here again.
California.
Yeah. Hello from Portugal. So
There
we
we
are
go. Two good friends from different sides of the world to bring you some fabric talks, some fabric topics for you to go and research and learn a little bit deeper on things that are around fabric. Chuck, we had to have our, like a few sessions already, right? This is the fourth one, so we had three already, right?
yeah, exactly. So we had some sessions about security that it's my topic, and we had a great one regarding to data storage that you were talking about to us. So and today
Exactly.
I
Yeah,
think
you are
we are
focusing
going.
on security, and
Yeah.
I'm focusing on some data structure that DBAs that are usually into things. And when you come to Fabric, like how does my knowledge apply to it, right? Our friend
Yeah.
Cecilia is online. Hey, Cecilia, nice to see you live there on LinkedIn. For those of you who are connecting live, we are both on LinkedIn and YouTube. So shoot questions, right? Cecilia, I saw your posts. I saw your have a few conferences we are talking. So good to have you here. All right, Chuck, let me just refresh here my browser because it
Sure.
seems in the browser that my YouTube thing here was not following questions. Now I see people there. Okay,
Okay.
there we go.
There we go.
So yes, we had two security talk. Last week was super cool, man. That one lake security that's come. Actually, one security, right? The actual name is one security, right?
Yeah, well, the name has changed a few times, so I call that One Lake Security. So
Oh,
let's
that's
let's
how I
roll with
heard
that
it from.
one.
It was from you. All right. So we had, last week was on link security. If you have missed previous sessions, please go ahead and look at the channel, Lacerda Data Labs channel. We have a playlist there with the videos that are already published. And yep, we are here today to talk about the indexes. I'm a
Yeah.
SQL Server DBA. I'm coming from SQL Server background or Oracle or Postgres, and now there is this fabric world, and in this fabric world, I went to the database they have there, kind of their warehouse they have there, the SQL whatever, and I tried to create an index, and it slapped me on the face. There's no
No,
indexes there.
it's a where my index? Where are my index? So I don't know. I want to have an index because there are many reasons to have an index. So
Yeah,
tell me,
performance
Armando.
reasons, right? We want to have
Exactly.
indexes because we want to have better performance, right?
Yeah, exactly. So I used to be a DBA in the past, and I used a lot of index to improve performance on my queries and my reports and so on. So if you are coming from the relational database, that index are important. This is the session that where Armand is going to explain to us. So I'm really excited to see what you're going to bring to us, Armand.
Yeah, perfect. Yeah, let's dive into it. A few recaps. We all on the first session. If you have missed, I mean, the second session. First session was Thiago talking about the copy into and the security for copy into to bring data
Yeah.
from outside Fabric into Fabric, right? So that was
Okay.
the very first video. The second one was me talking about how the data is actually stored in Fabric and the whole idea of Delta tables and Parquet files and all the structure around it, right? Dictionaries. Actually, Thiago, we're gonna do a B side on that one because the demo is kind of trimmed in there, was constrained in space. So I'm gonna invite you to a B side of that one so you can dive deeper on that one. But on the second session, that was the topic, right? Our tables, they are not in a proprietary format on a proprietary data file. Our tables, they're stored as files in one lake, right? That's
Yep.
the one thing we have learned in there. So if you want more information on that one, go back to the second session of this series. And this one here, will kind of a big tag on that one, and we will see why indexes are not around there. And Thiago, I'm gonna do something different today.
Tell me.
TEDx, right? I'm going to use a blackboard. Let's see here. I got my pen and I got the
All
blackboard
right.
here. So
It's
let's
a
bring the blackboard and let me make myself dummy by writing stuff. I'm really bad
that's
on.
even better. So I really like drawing things. So it's easier for me to understand concepts or architectures. So well, that's good. Great
Okay, let's
idea.
see if it works. I hope it does. Right. So we have. Um, you already mentioned, and thank you for helping my presentation that one. When we have databases, we have OLTP databases, and like you said, these are transactional databases, right?
Hmm.
Transactionals. And we have analytical databases. Actually, just to follow the same thing, they call it OLAP. So I believe the people who are following along with us, they are pretty familiar with this. Analytical. All right, they're pretty familiar with this. The point in here, Thiago, that's very, that's the question of this session is, I need indexes, right? We're
Right.
used to do indexes for performance. I need indexes, but the main paradigm to break about here is indexes. They are important for OLTP profile, right? For the OLTP, for the transactional database, for the OLTP profile. Because when we do indexes, we usually do a point query. And a point query is the idea like, I want this invoice, I want this customer, I
Yes.
want this transaction, I want a particular record from a table or a collection of tables when there is a join going on. So I want a point query for one record or a few records, right? 10, 15, 20, perhaps even 1,000 sometimes, but it's to collect information about a transaction. That's the idea of the index, because
Mhm.
the data is all over the place, is scattered all over the place in my table. So I make, if I'm doing SQL Server, I may create a cluster index to organize the rows physically in the data file for a particular most common criteria, in a compound criteria, or compound criteria. But it's always that idea, right? It's one row or a small range of rows. And
Yeah.
when we do analytical, we don't do point query, right? This thing here does not translate here. What we do here is always a range query. For instance, when we go into analytical database, I'm like, what's the total sales for the month? And if you are like, just a store here around the corner here that sells like 200 items per day, your total sales for the month is not going to be a big deal. But if you are a large retailer, like here in the US, Walmart, what's a big retailer there in Portugal?
Uh, maybe I don't know, Pingo Doce, or it's a supermarket, or even
There
a
we go.
continent. Yep.
If you are one of these big retailers there, and you want to have a sum of the sales for a month, um, how many million rows would they have there, Thiago?
Oh, billions of rows. It's
Billions of rows. So when we get to range query indexes, they don't help, right? Let me see here. Get this guy here. Erase you. So indexes, they don't help when we are doing a range query. What actually helps when we are doing range query, and here we go, white again. What actually helps in here is physical physical what how the organization. There is another name for this, but physical, or let's say ordering. Let's put it. Let's write it as ordering. I think it will be easier for everybody to follow. Physical ordering. Physical ordering. What is physical ordering, Thiago? Physical ordering is the idea, if you come from SQL Server, is the idea of a clustered index. A clustered index is when you get the rows of the table lined up, organized in the disk physically when they are stored in a particular order or sequence, and you follow that order,
Okay.
right? Say that again.
No, no, that's okay. Yeah, I would say it's kind of index for your book, right?
Is
So you
it
can. Oh,
is the cluster? It is the idea of the clustered index in SQL, right?
okay. Yeah. Okay. Yeah.
Yeah, is the idea that because when you create an index, you create a secondary structure mapping or shadowing portions of the data you have on the table. So you
Okay.
traverse that and then you go to the table. But when you do a clustered index in SQL, the actual table is the index because the table is physically organized. And the idea for analytical processing is to physically organize the tables because you are not the table but the rows, right? Physically organize the rows because the idea is you are doing a range query, and what you want to do when you do a range query is a table scan. So in order to benefit, in order to have a table scan that performs well, you need to have the table, the rows on the table physically organized in a way that can do a table scan and get to the point, just to the range of data that I want, and it's in that range, right? It's in that particular range of the data of the tables that of the data that I want to retrieve for the range calculation, the aggregation that I want to do. Because what we do in analytical, it's always an aggregation of some sort.
Yeah, I would say that. So I think the best way to differentiate this OLTP and OLAP, so the analytical, it's always on top some aggregation. You don't want to
Yeah,
see the details. So, and the transactional, it's the opposite. You want to see the details. For example, go in a specific sales in a specific order. That's a big difference, and you put really well. So the physical order matters here, and that's what makes things faster.
exactly. So thank you for adding up to it. So big point is for those of on this first half of this session here in this live. The very first big point is, where are my indexes? Well, I don't want them anymore. It's not an effect of I don't need them anymore. The idea is I don't want them anymore. Because if I use index strategy to go back and forth after rows in order to create an aggregation, that's always going to be a very bad performance result. You're going to get the calculation done, but the performance is always going to be really bad. And that's why the previous session, when we discussed the Parquet files and the Delta tables, are so important for this, because now we're going to piggyback on that one and go to the next step. If that is the case, right? Let me see here. Let
But I'm
me
just curious, Armando. So if we don't need the index, how things are faster now?
exactly. Great question. Thank you for having me with the second part. So how do we get things faster? Imagine that we have your data, that's your table, and this table here is like 2 terabytes of data. And what you want to do, you want to create an aggregation, and you're going to make a calculation based on whatever criteria you come up with. So for now, just you got to have a criteria, because without criteria, you're going to table scan the entire table. And if that's what you need, that's what's going to happen. But if this table has some, of course, this table is going to have multiple columns. As we create criterias, we are going to be able to split this table into fragments, into parts. So if my logical table is 2 terabytes, I need to look into the table and think about what would be the most common criteria that I will always have besides other criterias on top of that table. For instance, let's say you're talking about sales. So you're always making calculations on top of states. So here in the US, we have 50 states. So regardless of what kind of aggregation I want to do in my tables, I'm always asking those aggregations filtered by or with a predicate on the state. So I want the sales for the state of California. Always I'm going to say the state. I'm always going to have the state. So if I'm always going to have the state when I'm doing reading from this table, I can organize the rows. Remember physical ordering, right? We're talking about physical ordering. I can organize these rows that all tables from California are here, all tables from Florida, because Cecilia is there, right? So all tables from Florida, all rows from Florida are here. And let's say all rows from Arizona are here. And because I can make these sections, right? I can create these separations. I can create those Parquet files in different splits. So I can have those Parquet files on those splits. And within these Parquet files, I can also organize those rows in here to be on individual suborders. Like I'm always going to have states, and most of the times I have date. Like I want the aggregation for sales for the week or for the month or for the year, whatever it is, right? I'm going to have the date. And as I add these predicates, I can have both partition. Oops. Cannot spell. Hey, Thiago, the razor again, look.
Oh, yeah.
There we go. Let's go. Yeah, partition. I can have both partition pruning, which means based on the state that is in your criteria, is in your predicate, I'm going to skip some files because those files are for California, not asking for Florida or Arizona this time. So I'm going to work with these files. So I'm not doing a full table scan because if this is for California and this is for Florida and this is for Arizona, I'm going to skip. I'm going to not even touch those files or look into those files because your criteria is about California. And if your criteria is about California and you're asking for a date, usually I can organize the rows within the files for California by date. And when I do, that organization, there is this technique that it's applied to the Parquet files, right? So these are my Parquet files, just for reference. When I go to the Parquet file, say, organize the rows coming in when writing to the files by this particular column, like the date, it will make a small, so that is California again, that file there. It will create small clusters or segments based on the date that I have specified. And if I say, I want to work with, all, I want to total by the week, the second week, or by the first half of the month, and these things, there is a technique that is applied within the Parquet file that will skip these sections. Like this is the first week, this is the second week, this is the third week, this is the fourth week. So it will look, I'm looking to first week. There is nothing on the second week, for the second week. So I'm going to skip to the third week and go back to the fourth week. which means that when it's loading the file into memory and it start looking into the structures into the file, it can bypass, and that's what they call the Z order. Because the
That's
idea of the Z is not the letter, is the zigzag. It can skip portion, go to here, there is nothing after that, go to the next section, there's nothing after that, go to the next section, and keep skipping sections within the memory structure inside the file. So the bottom line of this, since I just shared a few of the internals of how this works, the bottom line of this is, as I organize my file and the data structure within the file with the basic predicates, the predicates that are always there, criteria, right? Predicate or criteria. The files and the structure within the file will be organized on those to allow for partitioning, pruning, and also to allow for memory structure skipping using that technique of the Z order. And that is how we improve performance. It's not by using indexes, it's by using by telling by telling Fabric which columns will be used most commonly on my predicates. So the information is organized in a way that it can be pruned out. Cool, right?
basically, that's really cool, Armando. So, if I got it right, so you're telling me that we are going to organize the packet files into a small cluster of data where they are organized physical, or they are physically organized, correct?
Exactly. Yeah. Both the
Oh,
files and the data within the file. Now, what is important to keep in mind here, Thiago, you're correct. And what is important in here is for you to feel it, you that following along here with us, for you to feel this in as a performance benefit, you need to you need to have a large volume of data, because none of this will make any impact if you're working with like 1 GB of data. We used to say, right, Thiago, that 1 GB is a lot of data, but nowadays, like
yeah,
1 GB is it's in the tip of this cable here, right? If
exactly.
it's
So,
right there. So
so,
we want to have, I mean, for this thing to make difference, you're talking about hundreds of gigabytes of data. And in my case, in the project I'm working with right now, it's in the magnitude of terabytes of data. I'm dealing with a few hundreds of terabytes of data, and I need this to get this thing for performance. Because when this gets to Power BI or someplace else, if it's not well organized like this, when populating memory, it's going to blow up memory, and Power
yeah,
BI will complain about that, right? Or if you're doing interactive queries using the Fabric portal, it's gonna cost so much scan that you're gonna be gonna have 2 drinks of coffee waiting for the result to come back, right? So
yeah. That's really cool. But how can I apply this the order, Armando? So what
the
I
Z
have to do?
order.
What I have to do?
So it depends. It's a great question. Thank you for the question. And it depends on what in Fabric you are dealing with. Like if
Okay.
you are if you are in Fabric and you come to a warehouse, and you are dealing with, when you are in a warehouse, your data in one lake is stored the same way the data, like if you're in a lake house, right? It's just delta tables, and they are there as files, so no change. But when you are working in a warehouse, let's see here, I'm not sure it's tables two. Let's take a look at this. Take a look on this one here. If I, oops, can I drag you? There we go. Yep. The endpoint is here, but it's not showing me the file system. I thought it would show me here the file system. But the point here is this, Thiago, to your question, right? How do I take advantage of this? If you are doing the warehouse, you have pretty much no control, right?
Okay.
Because the warehouse, the beauty about when you use Fabric Warehouse is as you bring data into the warehouse engine will look in your data, will look into your data, and will populate the memory with the chunk of data, how many gigabytes fits in there depending on your capacity and other things. Organize that and make all the decisions for you in terms of which column has less density, right? It's
Mhm.
lower cardinality, and organize by that one in the hopes that your query will use that one. And as you do your queries, that the warehouse team, they have their processing there that kind of sees what's going on and try to create caches and things around. So to your question, if you are in a warehouse, you don't do anything. You just bring it, and the warehouse will do its best to calculate
Okay.
the Z order and partitioning as well.
Okay.
But if you are in the lake house, then the control is on your hand. So look at this. I'm going to use our friend Copilot to create some code. Look at this. Write, whoops, write me a PySpark code to create a table with partition on column state and organized by date on the Z order. And of course, let's see, Copilot is like, am I talk to another Copilot or is that a human being? So for now, a human being. I have no implants yet. So that's how you do it, Thiago. See, it's
You use
coming.
Copilot.
Yeah, it's coming. So there we go. We here partitioning by state. So when we do this
Okay.
in our in our script, it will create a folder and break up the create multiple folders based on the
Mhm.
values that shows up on the partition.
Is this
And
the same for SQL Server partitioning that if people are coming from SQL Word, is the
mhm.
same concept or is it different?
It is in the SQL world, the partition is it's the same concept, right? But the
Okay.
thing is, in the SQL world, the partitioning element is tied up to the proprietary data files.
Yeah,
So
I know.
you're going to be creating data files and aggregating those, associating those data files to a partition criteria, and data coming matching that partition criteria will go into those data files, and
Okay.
you're doing updates and all of that. As we have seen before, delta tables, they are read only, right? You read once, you write once, and you read many. So as we add new data to the state, more files will be added to a folder in here. So the idea is
Mhm.
exactly the same. The implementation is radically different,
Okay, got it.
right?
Really
So
good.
here we are, you see, partition by state. So we can do partitioning pruning there. And down here, optimized by the column we have requested. In that case, actually, I asked for a date, it's putting age there for whatever reason. It's Copilot. But that's the point here. So this one will make the memory structures, right, to be optimized to do full scans on the memory structures that were loaded from the files. Or they were populated from the files based on the dates. So the hopes
Okay.
in here is I'm not going to use indexes. I'm going to use figure out which columns are used most commonly. And when I filter by those columns, the result is well suited for a memory structure that can be full scanned back and forth without performance compromises.
That's
And back
great.
in
That's
2012,
amazing.
there was this white paper that was published by Microsoft way back in 2012 on analysis service time. So this one is way better. That says that using this, the very pack engine can run through about 12, 14 million rows in less than a second. So that's
Yeah.
the hopes. we can use this thing here to narrow it down to a particular set of data in memory that will work well with whatever is going to come and consume this.
Okay, that's amazing. That's really
Super cool,
cool.
right? Thank
Yeah.
you, Copilot, for writing the code for me.
It's very simple command that you need to run, and you're getting a
Yeah,
great performance. Pretty cool.
exactly. One last thing to wrap up. We are on time, so it's time to wrap
Okay.
up. Uh, all of this is open standard. This is there for the
Important.
Delta table and the Parquet files. It's just there, right? You can use this. But when Microsoft does this, the Microsoft has built up, and you are Microsoft, you know that. I'm telling you, I'm preaching to the choir. But when Microsoft designed this, they created secret sauce to make this work even better, which is called the V order. So
Oh,
for our folks that are watching online, our time is up. I have to better time my talks here. But take a look on the V order and know this. The V order helps in processes on tables that are already, are good to serve BI or analytical or even AI processes. V order usually usually hurt when you are in a medallion strategy and you are moving data from bronze to silver and from specifically bronze to silver. When you go silver to gold, they are ready for presentation. You want to have the V order in the gold tier, but the V
yep.
order on the other tiers, on the silver and the bronze, you should skip them because if V order organize the data in a way to support query even better, but will hurt you in performance when doing transformations from tier to tier. So avoid the V order in the previous tier. Make sure you have them on the gold tier or whatever tier you have to support the people who are going to consume your data. Right,
Yep.
Thiago?
Right. That's a good one. So it's a kind the penalty here is on the right side. So you're going to have a performance degradation when you write your data using a V order. So that's why we recommend this to only have in your final layer.
There we go. Perfect. So thank you so much for those of you who are online watching there. I don't see any questions coming up. If you have questions later, please make sure you join us and sign up for our sign up and subscribe, as people say, right? Sign up and subscribe to our YouTube channel. Leave your comments there or connect with us on LinkedIn. And next week, we're going to be back with Thiago. Thiago, what's going to be our topic next week?
We are going to see how to lock your workspace. So, and make it even secured to your data.
Even more secure. Nice, nice. So more secure topics with Thiago next week. Thank you so much for attending, and make contact, sign up and subscribe, connect with us on LinkedIn, and we'll see you next week.
See you guys.